So in the first part of analysis of continuous beam, we have created the model of the continuous three-span continuous beam. So that has been the part which has been completed so far are geometry, properties, supports, loading. That have been completed, and we have got a simply three-span continuous beam with loading like this. Now the next part is analysis and design. So click analysis. Click analysis commands, click perform analysis and click all add. This is with regard to analysis. Then with regard to design, click design, select concrete, select the country code IS 456. Then select parameters as we do ever, bring all the parameters left side. We have FC, press Control Fi main, Fi secondary, maximum main, maximum secondary, minimum main, minimum secondary, click OK. And before defining defining these parameters, select the beams, all the beams. So selection can be done either by pressing Control and selecting the beams, or window selection could be made. So you can select all the beams by clicking like this. Now go to define parameters, click FC, say characteristic compressive strength to be 20 Newton per mm squared or 20,000 kN per meter squared. Assign Fi main, let the main steel be Fe 500, so 500,000, click assign. Fi secondary, let it be Fe 415 steel, so 415,000, assign. Then maximum main, let it be 16, assign. Maximum secondary, let it be 12, assign. Minimum main 12 mm, assign. Minimum secondary 8 mm, assign. And close this. Go to commands, design beam. You want to design this as a continuous beam, so design beam, click assign. We want to take off, so click take off, click assign, close. So this completes the pre-processing of the three-span continuous beam, right from geometry, assigning the properties, giving the support specifications, giving loading, different types of loading, giving analysis command and design command. The next part is processing. We need to run analysis. So click run analysis, click save. So at every time we need to get analysis successfully completed. This dialog we should get, so that we have done everything correctly. If we have done everything correctly, then we will get it displayed like this, or else some error message will appear. So we need to rectify the error, and then we need to redo. So click done. Now we are in the post-processing stage. That is, we need to see the bending moment diagram, shear force diagram, concrete design and all. So click post-processing, click apply, click OK. Maximize this screen where we want to see the bending moment diagram and all. So click MZ, so the bending moment diagram will be displayed. You want to see the values, we need to annotate the values. So click annotate, click beam results. I want bending moment at the ends, bending moment at the maximum bending moment and bending moment at the midpoint. Similarly, shear at the ends, maximum shear and shear force at the midpoint. Click annotate, click OK, close. So now we can see the bending moment diagram with values. If you want to see the shear force diagram, close this bending moment diagram and then click shear force diagram, get the shear force. So since here we have linearly varying load, we have a parabolic curve for shear force diagram itself. Next, if you want to see the design, the reinforcement design, you can click on either individual beams and then you can see the results. So select the beam cursor, double click on span AB. So span AB, the geometry, property, loading, the uniformly distributed load, shear and bending. This is bending moment diagram and this is shear force diagram. Deflection, take Y direction, you can see the deflection, concrete design. So 212 at the left support, 312 at the right support, and at the bottom we have 212 and shear reinforcement 8 mm dia, 300 mm center to center. Then if we click on this beam, that we can see, say, geometry, property, loading, shear and bending. So this is bending, and if you want shear force, then see shear force will be here. So deflection, select Y direction, concrete design. So 312 at the left support, 212 at the right support, and 212 at the bottom, and 8 mm at 300 mm at the shear reinforcement. Now span, third span, we can see geometry, property, loading is central point load, shear and bending. So this is bending diagram, and on shear force diagram will be the shear force diagram. Concrete design, 312 at the left 10, 212 at the right 10, and 212 at the bottom. 8 mm dia to 195 mm is the shear reinforcement. We can see the output through utilities option also. So you can see the analysis output. Just click output, then it will a separate window will open, get open. Maximize this. Here you can see the concrete design, especially beam. So if you click on beam, say beam number 1, that is the first span of span 4 meters. Size is 230 mm by 450 mm. Cover is 30 mm as per IS code. Then this is the summary of reinforcement. What is the top reinforcement required for span AB? What is the bottom reinforcement? This is the area of steel. And in the next table, it will give the number of bars. Say for span AB, at the top, what we need. So at the left support, you'll have 212, right support 312 at the top. Bottom uniformly, you have 212 at the bottom. This is shear 2 like the 8 way steps at 2 or 3 center center. Similarly, the mid span, the central span, BC. So the span is 5 meters, then 230 by 450 mm. This is the reinforcement. So 312 is required here, 212 at other portions, and then 212 at the bottom, shear reinforcement. Similarly, the last span CD. Span is 3 meters, 230 by 300 mm. Summary of reinforcement and the number of bars. Similarly, we can see the concrete takeoff. That is the total volume of concrete required for this continuous beam is 1.1 cubic meter. And this is the steel reinforcement requirement. Say 8 mm dia, 179 Newton is required, and 12 mm dia bars, 427 Newton is required. So you can convert into kg and then to tons, and then we can go for procurement of the steel for this continuous beam. Then close this.